In this video, we will talk about parallel and perpendicular lines. We talked about different types of lines, and we had a positive and a negative and a zero slope. In this one, we're going to talk about parallel and perpendicular lines. Things to kind of know about parallel lines is that if I were to graph two lines, lines will be parallel if they're going in the same direction. So basically, parallel lines have the same slope. Okay. So you also have perpendicular lines. So if you have a line that goes like this, a perpendicular line would be going the opposite direction. And basically what they're doing is forming a 90-degree angle. Okay. So perpendicular lines have negative reciprocal slope. So not only is it going the opposite direction, so see how this is increasing, the other one's decreasing, but now the rise and the run are just switched. Okay, so one of the things to kind of just notice is that this is going to be key to doing these types of problems when we're doing parallel and perpendicular lines. Okay, so let's just start off with a couple of examples. So is 4x minus 7y equal 10 and 7x plus 4y equal 1 perpendicular or parallel or neither? Okay, so this funky looking upside down T just basically means perpendicular. And these two lines just mean parallel. Just for me, I don't want to be writing it over and over again. Now remember, when is it going to be neither? So neither is going to be if they don't have the same slope and if they're not negative reciprocals. Okay. So now let's look at both of these equations. So let me write them in a different color. So let's say you had 4x minus 7y equals 10, and you have 7x plus 4y equals 1. So let's solve for y. So I'm going to minus 4x to both sides. So you have negative 7y equals negative 4x plus 10. So let's write it. So what I'm doing is I'm writing it in y equals mx plus b form. So I'm dividing it now by negative 7, everything by negative 7. And what I'm going to get is y is equal to positive 4 over 7x minus 10 over 7. Okay, so that's this guy. Now what about the other one? So I'm going to solve for y to kind of write it in y equals mx plus b form. Yeah, for y equals negative 7x plus 1. I'm going to divide by the 4. So now here y is equal to negative 7 over 4x plus 1/4. Okay, now let's compare. So comparing both of these guys, you'll see all you want to look at is basically the slope. Are they the same? No, they're not the same. So they're not parallel. Are they perpendicular? Well, how do we know they're perpendicular? They have to be negative reciprocals. So are the signs different? Yep, the signs are different. One of them is positive, one of them is negative. Are they flipped? Yep, they are flipped. Then the 4 over 7, if I flip it, it becomes 7 over 4. So these two lines are perpendicular. Okay, so looking at them, making them into y equals mx plus b is basically the easiest way to kind of do it. Okay, now let's do a problem where you actually have to create a parallel line and a perpendicular line. So let's write an equation. For a line perpendicular to h of x is equal to negative 2x plus 4 and passing through -4, -1. Okay, so we want to find an equation of the line that's perpendicular to this line and passing through this point. Okay, so first of all, we have this equation, okay, and we want to find a line that's perpendicular to this equation. So first of all, what can you tell me about the slopes? So if the slope of this guy is -2, the slope of the other line should be equal to the negative reciprocal. So if this guy is negative, this guy's going to be positive, and the opposite, the reciprocal of 2 is going to be 1/2. So the slope that's perpendicular to that guy is going to be 1/2. And it has to pass through this particular point. Well, we know how to find that equation if we have a slope and a point. We just use y minus y1 equals m times x minus x1. So y minus y1 in this case will be this -1 equals m, which is going to be this 1/2 x minus x1, which is going to be this -4. So it's going to be positive. So I have y plus 1. Let me FOIL this out. So 1/2 x. Half of 4 gives me 2. And then I can subtract by 1. Y equals 1/2 x plus 1. Okay. All right, and that's basically it. Okay, so now let's do another problem. Okay, so write an equation. Write an equation for a line. Now let's look let's do parallel. Parallel to g of x equals 3x minus 1 through 4, 9. So let's say we have something like that looks like that. Okay, so now we want to write an equation. Okay, so and we want it to be parallel, okay, to this line. And you see that the slope is 3. So that means that the slope for the parallel line is also going to be 3. So we just write it again. Y minus y1 equals m times x minus x1. Okay. So now we just have to plug them in. So y1 in this case will be 9. And in this case is 3, x minus x1, which is 4. So let me distribute this. Y minus 9 equals 3x minus 12. And then I add the 9 over. And then y is equal to 3x. And then this guy is just going to be -3. Okay. So if I were to graph these two lines, this line will go through this one and it will be parallel to this guy. Okay. All right. Wrap up this chapter, we will do this word problem. So you can take a, you can pause it and then you can just type up, not type up, I'm tired. You can just write out the problem if you want. So a town's population has been growing linearly. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. So assume this linear trend continues. So predict the population in 2013 by finding a linear model, and then identify the year in which the population will reach 15,000. So some of the clues that you kind of have in this problem is that you know that this is going linearly. Okay, so let's try to get all of the information that we have. So the first thing is that the population in 2004 was 6,200. Okay, so in 2004, so you can kind of write it as point 2004, it was 6,200. I think that's what it was, right? And then in 2009, it was 8,100. So kind of like imagine that if you're graphing them, here is 2004 and here is 2009, then you have this point and then you have this point. And you can, in this following a linear trend. Okay, so it's following this particular pattern. Okay, so first what we want to do is find a linear model, okay, because we want to predict this guy. So one thing that we can do is, well, we have 2 points, we can find the slope of this. Okay, so finding the slope would be y2 minus y1 equals x2 minus x1. Okay, so I can just say x1, y1, x2, y2. So this is just going to be 8100 minus 6200 divided by 2009 minus 2004. Okay, so let's go into our calculator. 8100 minus 6200 divided by 2009 minus 2004. And what I ended up getting was 380. Okay, so that's basically our slope. Okay, so every year your population tends to grow 380 people. Okay, now we need to figure out the linear model. So remember, y minus y1 equals m times x minus x1. So we can choose any point. Since I labeled this as x1, y1, we're going to just use that one. So y minus 6200 is equal to m, which is 380, x minus x1, which is 2004. Okay, so now we're going to distribute y minus 6200 is equal to 380x, and let's multiply this number, which is going to be ginormous, 2004 times 380. That's going to give me 6761520, and then we're just going to add this number to the other side. So y is equal to 380x, and then whatever the heck this number is, negative 761,520 plus 6200, that gives me negative 755,320. Okay, so this is the linear model that we're going to use. Now, what are we trying to figure out? So we're going to use that linear model to predict the population in 2013. So where am I going to plug in this 2013? Into the x. So 2013 goes in here. 320. So we're going to put that in our calculator. So 380 times 2013 minus 755,320. And I'm going to get 9,620. So in 2013, this is what the estimated population will be. Okay. All right. And now let's do our last problem, which is basically identify the year in which the population will reach 15,000. Okay. So what does that mean? So now we have our equation. Y is equal to 380x minus 755,320. Now in this case, we want to figure out what is the population when it'll reach, or what was the year when it'll reach 15,000. So where's 15,000 going to go? Well, that's just our y. 15,000 is our y. And we're solving for our x. Okay, so let's just solve for x. So now I'm going to add this guy over. Okay, so 755,320. That thing goes away, so I have 380x is equal to whatever the heck that is. So we're going to have 15,000 plus 755,320. That's going to give me 770,320. Okay, and then I'm going to divide by 380. So x is equal to, so that divided by 380, I'm going to get about approximately 2027. Okay, so in the year 2027, that's when my population is going to reach 15,000, assuming this is a linear trend. Okay, now obviously we know that population kind of doesn't work that way, but assuming this is a linear trend, this is where the population will be. Okay.